All right, this continues section 6.3. We're going to see our special cases, the inconsistent system and the dependent system. So our first system here, what we're going to look at, we're going to focus on the x's, or at least I am. And so my first step is, in this case, to make equal but opposite, since how they're already in the same form. So I'm going to multiply the top equation by a negative 2, which will give me a negative 4x, and then minus a 6y, and then anything times 0 is still 0, and now I'm going to add these together. And so the adding together step gives me a 0 and a 0, which the y's I didn't mean to happen, so I'm going to write down a 0. Remember, don't write 0y, just write 0. And then 3 plus 0, which is 3. And what I see here is a false statement. And when I have a false statement, what I want to do is I want to remember that that means that there is no solution for these. So I'm going to write that this is a null set, and that's going to be my solution. Remember, false isn't your answer, 0 equals 3 isn't your answer, saying that it's an inconsistent system is not an answer either, that just the null set is your answer. All right, now the next one, same thing. I already have them both in standard form, so I'm just going to focus my attention on one variable. I'm going to focus on the x's again. So I'm going to multiply my first equation by a 3 and then add the equations together. So 3 times a negative 1 gives me a negative 3x, and then 3 times 5, which gives me a positive 15y, and then 3 times a negative 1, which is going to give me a negative 3. And now the next thing I want to do is I want to add these two equations together. So 3x minus 3x is 0. That's what I wanted to happen, so I don't write anything. Negative 15y plus 15y. I didn't expect this to happen, so I'm going to write a 0. Remember, don't write 0y, just write a 0. And then 3 plus negative 3, again, I didn't expect that to happen. I'm going to write the 0 there. And then I have the statement 0 equals 0. Well, that is absolutely a true statement. And remember, when I have a true statement, that means that I have infinite solutions. So I'm going to write infinite solutions. And that will be the solution to this equation. Remember again that the solution is not the true. It's not 0 equals 0. None of those things are actually the solution. The solution is actually that there are infinite solutions. So that wraps up solving the equations that are special. Now what about one with fractions in it? Fractions can be our nemesis. So the cool thing about fractions is that we can eliminate the fractions from our process. And I recommend that we eliminate fractions from the process before we ever start to try to do elimination. Some books and some teachers will tell you, oh, you're going to do elimination and fraction removal at the same time. I don't think that's absolutely necessary. So I'm going to go ahead and clear this top equation by multiplying by the LCD. And the LCD, remember, is the 9 here, because 3 is a factor of 9, so the largest one, 9, is going to be the LCD. 9 times x is going to give me 9x, and then 9 times 1/3, 3 goes into 9 3 times. 3 times 1 times y is 3y, and then that's equal to 5/9 times 9. 9's canceled, 1 times 5, which is 5. And now that first equation has no fractions in it. And now I can pair that up with the second equation, 8x plus 3y is equal to negative 16. And from there, this process becomes much easier because all I have to do is multiply through by a negative here, here, and here, and then I can add these things together. And I have 9x minus 8x, which is x, and that is going to be equal to 5 plus 16, which is 21. Now once I have that, I can put that back into one of my original equations, and I can solve for y. I'm going to go ahead and put it in the second one here, and we're going to see that we have, let's see, 8 and then 68, 168, we're adding the opposite here. So we're going to end up with a really big number, and you'll be dividing by 3. I'm not going to get to finish this in this video. I'll see you in the next one for this final solution. You should try to finish solving it.